Hi, what's up everyone and welcome to my new C++ video. In this video, I'm going to talk about data types in C++ and more specifically fundamental data types. The first fundamental data type is void, which is an empty set of values. We cannot have arrays of void, we cannot have references to void. However, we can have pointers to void and declare functions with returning type void, which we will have a separate video about these in future. Basically, in C++ language, what happens, we have data models which specify the size of fundamental types depending on what kind of platform computer architecture we are using. We have basically the most common following data models, and then here I'm gonna write it. And then for 32-bit systems, we can have LP32, such as Win16, which where int is 16-bit and long and pointer are 32-bit. And then so we have another one. We have ILP32, such as Win32 and Linux or Unix based systems and Mac OS, where int, long and pointer are 32-bit. And then we could have another group of data model for 64-bit system, like LLP64, such as Win64, where int and long are 32-bit and pointer is 64-bit. And we could have another group called LP64, such as Linux or Mac OS, where int is 32-bit and long and pointer are 64-bit. Okay, these are like data models we could have in C++ language, but of course for more information you can just Google C++ language data models, and then you could find a clear description of all of these. And okay, let me go and focus on fundamental data types. And then the first one I want to talk about is integer type, and basically whatever comes with int. And it's called integer types. Is the most basic integer type is int, and it can come with modifiers that modify integer type. And we can have sign and size modifiers. Basically we have sign modifier, which is signed and unsigned. These are keywords for sign modifiers. And then we could have we have a keywords for size modifiers, which is short and long. These are keywords, token keywords, for size modifiers. And then for new C++ version, C++11 and new versions, we have long as a size modifier as well. Of course we can combine, so all of these, and this is integer type and is int. And then we have sign modifiers and size modifiers. Of course we could combine all of these together, and then we could have, for example, int alone, or like sign, or short alone, or long alone, or signed, and then we have signed short or signed int, and then we have signed short int. And then so okay, let me give you like group of examples about this. And then and then you will understand about the difference between these groups. And for printing the max and minimum numerical limits each of these groups that can take, I'm gonna include a library from C++ standard library. Here is called include limits, and basically this one will give me min and max numeric limits of the data types. Okay, and then what I'm gonna do, I'm gonna give you here some examples, but before we move forward, I'm gonna group all of them based on the size of these integer types. The first group that can take 2 bytes of memory, and then remember 1 byte is equal to 8 bit, 2 bytes is equal to basically 16 bit, and these groups are short. And then we have, if we combine this int with these size and sign modifiers, we will have short int which takes 2 bytes, and then we have signed short, and then what else we have? We have signed short int, again it takes 2 bytes, and then we have unsigned short and unsigned short int. All right, these are the group that takes 2 bytes. And then let me give you examples. For example, I'm gonna print out their size and then minimum and maximum limits they can take. Okay, for beauty, I'm gonna type size of short, for example, here, and then is space, and then I'm gonna use command in C++ called size of, and it will give me a size of like integer type, or size of, for example, character or a floating point, and then we will talk about later. And then size of short, and then what else I want to know? I want to print it in bytes, and then what I want to do here, I want to also print the minimum and maximum limits. Okay, min value that they can take is, I want to use numeric limits short, and then I want to use scope resolution operator and min function from them. And then I also want to print max value here, and basically again I will call, happen here, I will call this numeric limits, and then pass short as a type here, and then call max. And then I will have end line here. All right, this is gonna print the size of short, which is, I know, is 2 bytes, and then the minimum and maximum limit that it can take. Okay, and then let me print it, and I will tell you where this minimum and maximum limits comes from. Okay, size of short, of course, is 2 bytes, and minimum limit is -32,768, and maximum value is 32,767. And you might wonder, like, where these numbers come from. And okay, let me show you here. So basically what happens here when we have short, and then it's 2 bytes, and 1 byte is equal to 8 bit, and 2 is 2 times 8 is equal to 16. But short by default is signed. Okay, 1 bit goes to the sign. okay, we have 15 bits. And then, okay, what we have, we could write range for short is minus 2 power 15 to 2 power 15 minus 1 because of 0 here. And then if you do the math, and then you will have the range, this is equivalent to minus 32 768 to 32 767. And basically, if you initialize a variable, and that we will have a discussion about this in another video. If you initialize a variable with short, and then you cannot initialize it with, for example, with number is equal to 32,768. The max limit for short you could go is 32,767. Okay, the same thing I would say. So for, okay, let's try a couple of cases here, and then I'm gonna give you another example. For example, signed short int. Okay, and then another example for unsigned case, signed, for example, short int. I'm gonna copy this one and then paste it here, and then minimum value for here, paste, and then minimum value for here, paste. All right, so if I print this one, and then again signed short int is equivalent, the size is the same, and minimum and maximum value are the same, and then so you could see, but depends on what kind of uh, data models you could use, and then values might be different, because, for example, if you use Win16, and then you will have some sort of different values for this. Okay, and then let me give you another example. For example, for the case when we have unsigned short int, I'm gonna copy this one here and add like unsigned here, just to give you an example about unsigned case. Unsigned short int, still 2 bytes, and then the maximum and minimum limits you will see they can take will be different than this guy here. And then the reason why they will take different value, because it's unsigned, and then we don't have the negative part, and it starts from 0, and then we will have 2 power 16. And then if you do 2 power 16, and it will be like 65,535. And then basically the max and min limits, they can go from 0 to 2 power 16. This is equal to 65,535. And then of course you will see it here, the maximum and minimum limits they can take for when you use unsigned short int. Still the size is 2 bytes, but the minimum and maximum value is different compared to this case when we have signed short int, short, or short int, or signed short. They are the same, at least for my computer. And the next group, okay, the next group that is a group that takes 4 bytes of memory. So, and then I'm gonna group them here. Okay, takes 4 bytes, and then basically 32 bits. And then I have int here, which takes 4 bytes, and I have signed, okay, takes 4, signed int, and then I have unsigned, and then unsigned int. Okay, and then what else I have, at least in my computer? So this also depends on the architecture of computer and what kind of data models So what kind of system I have, at least for my computer. And then so I will group them, and I will have another group that might takes 8 bits or 4 bits of memory. Okay, I'm gonna group them takes 4 bytes or 8 bytes. And then these are long, and I have long int, and I have signed long, I have signed long int, I have unsigned long, and then I have unsigned long int. Okay, these might take like 4 or 8 bytes. And then the last group, which basically if you use new C++11 and newer version, and these always they take 8 bytes. So takes 8 bytes of memory, and then these are long, and then I have long int, and then signed long, and then another one is signed long int. I'm gonna give you example for each cases. What I'm gonna do, I'm gonna copy this one here, for example, for a group that takes like 4 bytes, and then just for the simple case, and then just if you do just int, okay, and then you will see it takes like 4, and then for the case one, okay, let's do for example long int, and size of long int here, long int, and then we have what happened here, I don't know, long int here, and then we have long int here, and this takes so I will print this one for you, and then another group I'm gonna show you here is like let's take this, the most complicated one. Okay, signed long int. Okay, and then you will see what it takes, and then the minimum and maximum size for signed long int. Okay, and I will explain the upper and lower limits for them and where those limits come from. Okay, so what I have here, size of int of course is 4 bytes, and minimum value is minus this number and plus this number minus 1, and then 4 bytes is equal to 32 bit, and then by default int is signed, and then 1 bit goes to the sign, and then we have 2 power 31 2 power 31 minus 1, and then that's why we have like 47 here instead of 48. And then also the next group that might, for example, my computer is like takes 4 bytes, or depends on, for example, what kind of data models we are using, and then it's long int, it takes like again 4 bytes, and then the size, the minimum and maximum value is the same, like 2 minus 2 power 31 to 2 power 31 minus 1. And then the last one is which always take the last group that always takes 8 bytes. So 8 times 8 is equal to 64, and then I have like signed long int here, 64 minus 1 because of the sign, and then I will have 63, and then if you do the math, and then 2 power 63, and you will get this number. and then 2 power 63 minus 1, you will get this number. All right, and these are these are the numbers. Of course, you could do like combination of all of them, these shape and sign and size modifiers with int, and then for long, short, and then you will get you will get different memory size for each of them, and then you will get different lower and upper limits for each of them. I'm gonna complete this function and post it on GitHub inside of C++ folder, and then if you want, you can download it and you can practice. Okay, now I'm gonna move forward and then talk about Boolean type. And then what I'm gonna do some sort of cleaning here, and then because I'm gonna keep one of these here, I'm gonna do some sort of cleaning here, and then I have Boolean type here, so which is bool is a type, and that holds true, which is equal to 1, or false, which is equal to 0. And then of course you could prove it here, and then if I do bool here, it's just a number here, and then but it's bool here, and then bool here, and then we'll have, so size is equal to 1 byte, and then minimum and maximum value is equal to 0, and max is 1, and then and then the reason why is like, so you might ask, okay, 1 byte is equal to 8 bits, and then why it's just minimum value is equal to 0 and max value is equal to 1. And then just remember, and then when we have, so we cannot specify, when we write a computer C++ and computer program, when we cannot specify value inside of bit, and then basically the data type goes based on the byte, not bit, and then that's why, so we have the minimum value we can assign is like 1 byte actually, so 1 byte here. And then this is a Boolean data type. The next one is, I would say the next one is character types, char type, character types. And then here I'm gonna give you examples about char types. And then char is also, they take 1 byte, and okay, but depends on what kind of char we are using, for example. And then if we use char or signed char or unsigned char, and these take 1 byte, and because by default char is signed, and then 1 byte is equal to 8, is we will have minus 2 power 7 to 2 power 7 minus 1, and that's why you usually see like for characters, and we can go with from minus 128 to plus 127. Okay, just an example about for example how we can, so we can get the size of char here. So I'm gonna size of char here, and then you could see size of char here, and then char, and then I have char here, and then here what I'm gonna do, I'm gonna cast it into int, make it printable. So, int, and then you will see the size of char and then range for char here, what they can take. And then the size of char is 1 byte and minimum value is -128 and maximum value is 127. Of course, if you go with unsigned char, and then the value will be different from 0 to 255, because 2 power 0 to 2 power 8 minus 1. And then so if you do unsigned char here, okay, and then the value, the range will be different. And another group we have inside of char is basically is white char. And then okay, another group we have here is equal to w char t, is a like white character. And then so this white character takes 2 or 4 bytes depending on the compiler being used. All right, range for w char t is equal to, if you use for example a 32-bit system, is -2 power 15 to 2 power 15 minus 1, or if you use 64 it will be like -2 power 31 to 2 power 31 minus 1. And then basically this one is, if I want to make a note here, is a type for wide character representation. All right, and then if you use, for example, I'm gonna show you here, and then based on my computer system here, and then 64 or w char t, and then we have sign off char t here, and it again casting into int and to make it printable. And then if I run this one here, and then you will get something like, okay, what happened here? So size of the w char here, okay, and then if I run this one, yeah, so it's my system is like 2 bytes, and then from 0 and 0 to 65,535. And then but if for different system it will be different. And then of course, so we could use of course we can use char type array string, for example, using wide character, for example like char. And then so if we do it with char, and we will talk about this one in future. For example, if we use char type array string, and then for example easy C++ here, and then we can do like C out here, okay, chr, and line here. I'm just giving you one example, and then the difference will be like if we do like white character t here, and then name it like vchr, and then string here, and then we could do, okay, so we should add, okay, l as the prefix for wide character literals. Okay, we will have l, for example easy C++, and then for printing, and then we want use cout, we will use wcout, and then we'll have white characters and then end out. And then this is the difference between like character char and wchar t. And then so we use wcout. W is the prefix for operation like scanning, wcin, or printing wcout. And then we want to print or scan white char type strings. And then if you print this one, and then you will see something. Okay, I think, okay, yes, this is the mistake here, sorry about that. And then you will see, so what happens here, expected cout here, I have, okay, cout, okay, end line here, am I missing, oh, okay, sorry. All right, so you see like they can print like the same array of string, but we call them differently in different way. And then as you see here, okay, and the last group is a floating point type. Point type here, and then what we have float, and we have float as a floating point type here for single precision floating point type. And then we have double for double precision floating type, and we have long double for extended precision floating type. Okay, let me give you some examples here. Okay, for example, if I copy this one, and then the size for float is 4 bytes, and then the size for double is 8 bytes, and the size for long double is 16 bytes. And then of course I can prove it here. And then if you do float here, and then size of float, and then I don't need casting here. Okay, and then minimum limit, and then depends on, this is also depends on the computer you are using, but here I'm just showing you as an example, minimum and maximum numeric limits they can take. And then the same thing, so we could do with double. And then I want to do the same thing with long double, and then just to show you how much what is the maximum and minimum value they can take when, so like for within 16 bytes of memory. And then I'm gonna print this long double here as well, so add long here, and then size of long double here, and the minimum limits for long double, and the maximum limits for long double here. And then if I print this one, and then you will see like the, of course, sizes for float is 4 bytes, and minimum value they can take is very small, and maximum value for very big. But double is 8 bytes, and then the minimum value is significantly small, and the maximum value is significantly large. And of course you see here for long double is they take 16 bytes, and then of course the minimum and maximum values is like crazy insane, like small and a very large number. And then I think yeah, that's it. And then I'm gonna post all of these was different combination, and then about integer type and characters, and then floating type, the code for and relevant examples for each case on GitHub C++ tutorial, and please make sure if you want to if you want to do some practicing, and then just to download the code is public, and then you can, if you see like any mistakes or error, please feel free like to leave a comments. And also at the end, I will like, if you like the video, please make sure to like the video, and then make sure to subscribe to the channel for upcoming videos. And then I don't have I have not only about C++, and I also have like about other programming language which are coming soon. And I hope you like this video, and then looking forward to having you next video. And thank you so much, and have a good one. Bye.